Welcome to Arbitrum Day. We have a very special person here. I'm sure most of you know him. And we have the founder of Ethereum and the researcher of the Ethereum Foundation. Here with us is Vitalik Buterin. So yeah, let's give him a big applause.
So thank you much for the kind introduction. It's definitely good to see all of you guys in person. Hope you've been having a good day so far. So I would thought that since Arbitrum is an L2, hopefully you guys are still an L2. You're not an L3 yet, right? We should talk a bit about the role of L2s in the Ethereum ecosystem, and particularly like some of the different kinds of roles that L2s can have, right? So what is an L2, right? So an L2 is a system that is mostly, but not entirely off-chain, and which still gets its security guarantees from Ethereum, right? So I think today we tend to think of L2s as being like basically copies of the EVM that are like connected to Ethereum somehow. And like L2s did not start this way at all, right? Like, at the very beginning, the kinds of L2s that people had in mind were basically things like, like the Bitcoin Lightning Network and state channels on Ethereum, which don't even look like chains at all, right? So an L2 is like really this like much more broader and abstract concept, right? And it actually doesn't even need to be a chain. So some kind of system which is mostly off-chain and gets scalability benefits from being off-chain, but which at the same time gets security guarantees from Ethereum. L2s are a way of scaling Ethereum, and where by scaling you mean making the TPS, or I guess these days it's better to talk about gas per second go up, and at the same time make transaction fees go down. L2s are also a way of scaling Ethereum in terms of tech experimentation, experimenting with different programming languages, experimenting with different VMs, other kinds of technology, potentially privacy-preserving stuff, potentially, community and culture, and a whole bunch of other dimensions, right? So L2s end up having all of these different properties for the Ethereum ecosystem. So I think one of the ways in which we sometimes think of L2s is basically essentially L2s as Ethereum shards, right? So the original roadmap for scaling Ethereum basically what has been sharding, right? So basically you start off with a system that has about 15 transactions per second, and you do that by having this thing that everyone has to download, everyone has to process. And so instead we take that one thing, we split it into 1,000 things. Each node only has to process like one or a few of those things. And then you have some kind of cross connection between them to make sure that all of them share security, right? And L2s do actually implement this vision, right? And so basically the way that things are going now is, we have data availability and we have blobs. And so we have this space that is still protected by the entire Ethereum chain, but which at the same time, each node only needs to download a small portion of it. And so over time, the amount of data that gets put into blobs can start scaling up and up, right? Now, the original vision for sharding basically said you have enshrined sharding of data, and you also have enshrined sharding execution. This model basically says, well, we have enshrined sharding of data, but it's bring your own execution, right? But if you want, you can make an execution engine that basically just is a copy of Ethereum, right? And so if you have a bunch of L2s where each of these L2s just replicate the EVM exactly, ideally even have some way of immediately copying Ethereum hard forks, minimize governance, minimize any kind of logic that depends on off-chain mechanisms, ideally be based rollups, then you basically have an outcome that from a practical perspective just looks exactly like sharding, right? And so this is one of the ways of thinking about L2s and thinking about like how they fit into the growth of the Ethereum ecosystem, right? Now, there's also this kind of very different and very opposite way of thinking about what L2s can be, right? And this basically is thinking of L2s as being servers, but better. So, like, who here remembers private enterprise blockchains from like 5 to 10 years ago? Right. So, the core idea behind private enterprise blockchains, right, is basically that you have all of these like very mainstream use cases. Could be accounting, could be supply chain, could be healthcare, could be regulated finance, blah, blah, blah. And for these use cases, you need some kind of compromise between centralization and decentralization, right? Like you don't need like full-on, like cypherpunk grade censorship resistance, but at the same time, you do gain benefits from interoperability, you gain benefits from verifiability, you gain benefits from people being able to check Merkle branches and so on and so forth, right? And since then, I think the original vision of like consortium blockchains, right, had this idea that like you have like 5 banks or like 5 major companies come together and bring their own, create their own chain, has been mostly a failure. And I think the reason why it's been mostly a failure is basically because it ends up inheriting most of the disadvantages of centralization and most of the disadvantages of decentralization at the same time, right? Basically because what you have is you have a system where like the first 5 banks, okay, fine, they join and they all feel like, yay, we're building a system together, we can be part of it, right? But then once bank number 6 and then bank number 7 and bank number 29 come in, they're joining a system where there's like already an established power structure, established participants, and like basically, yeah, to them it still feels like they're just joining some kind of centralized thing that's controlled by a cartel, right? Like it's like you don't actually gain a lot of the benefits of like true openness that people are looking for, right? Like you don't have Etherscan, you don't have a connection to an open public network, you don't have these things. At the same time, if you build on one of those systems, then like you have to figure out how to do programming in distributed systems. You lose privacy, and like you might think you still have some, but the reality is like, okay, well, you're putting your data on a network where the only people that get to see it are you and all your closest competitors, right? And so from a privacy perspective, it actually doesn't make much sense, and so on and so forth, right? And so I think like the compromise between centralization and decentralization that actually makes a lot more sense is to basically say, you have an application, today that application is a server, you can keep your server, but instead we're going to add scaffolding on top to give users extra security guarantees, right? So you put roots on chain, you put proofs on chain. Ideally, yeah, like validity proofs, but you can also do fraud proofs if you have some kind of robust data availability. So you put proofs on chain, you put Merkle roots on chain, and you give your users assurance that whatever is happening on the inside of your system actually is following the rules. So you have high scale, you have high performance, and you optimize for a minimal delta for existing centralized infrastructure deployments, right? Because you keep your existing infrastructure the way as it is, and you just add a sidecar that makes the roots and the proofs, right? Now, there's what actually have been some versions of this, I mean, even within the crypto space, right? So exchanges doing proof of solvency, for example, like it actually is a Validium, right? If you do it with ZK Starks. I mean, even if you do it like the like 2013 era Gregory Maxwell way with fraud proofs, then like even that, right? It's like kind of like in the Validium, Optimium, like a range of things, right? So this is also like a category of things that like I actually think is valuable, right? It's if you have a server, like why not just like give your users more guarantees on top of it? So I think this is like one way of thinking about it that is like also really can bring a lot of new applications and a lot of new users as well. L2s as experimentation zones, right? So this is really the third way of thinking about what L2s are, right? Basically, like you're actually trying to do different things and you're trying to do interesting things, right? So, you know, you guys have Arbitrum stylus, so you know you have WASM. There's you know, L2s doing move. There's L2s doing all kinds of new programming languages. Potentially, yeah, you know, you can try to you know, make arithmetizations for snarks and starks of solidity or some kind of IR instead of the EVM, get some efficiency that way. You could have more exotic instructions, so you know, like intmax, basically doing a plasma-like thing that for ZK payments. You know, you have something like Aztec, which is making an entire new programming language that's really focused around privacy. So a lot of different things that you can experiment with, and basically using L2s to scale Ethereum, not just in the sense of increasing TPS, but also in the sense of making Ethereum available to people who like new and different kinds of programming languages, and to people who want the properties that you can only get with new kinds of programming paradigms, right? So this is a third thing that I think is also valuable. One fourth thing that I think is valuable is application-specific layer 2s, right? So application-specific layer 2s, you know, they can be centralized, like they can be servers. They could also be decentralized to look like networks. They could be based. They could even be just like EVMs and kind of EVMs where you can theoretically do anything on them, but the primary de facto user is one application. You could restrict it to be to one user. You could do a lot of different things. And a lot of the time, like, you know, there is value in just having an L2 dedicated to a specific application, right? So, you know, like World Chain got announced recently, and one of the motivations there is basically just like wanting, you know, the WorldCoin system to not really be like subject to other people's gas spikes. Potentially, you know, you might want to have your own application be written in your own language to do some more optimizations around that. You might want to do like, I don't know, potentially some kind of snark aggregation for cryptography. If you have a server, then like if you're trying to have a minimum delta from your existing setup, then you're basically turning your server into an app-specific L2. Right, so there's like a lot of different use cases for app-specific L2s as well, right? So this is like basically how I think about the space of like different kinds of things that L2s can be for Ethereum, right? So you know, I like triangles, I like grids. And this time it actually manages to be a triangle and a grid, right? You know, you got a trapezoid, or rather, you know, triangular prism, right? And basically, yeah, you know, like one axis here is essentially, like, are you being EVM purist? Are you being like experimental general purpose? Or are you being something app specific, right? And then the other axis is basically, are you being fully decentralized, or are you just like basically being a server with extra scaffolding, right? And like, I think many parts of this prism actually have some really valuable properties, right? And I think what's interesting is that we see examples in all of these areas, right? So, you know, we have like Tycho, which is EVM purist, type 1 ZK EVM based, like basically trying to be like as close to Ethereum as possible. Then all the way on the other side of the triangle, you know, the whole concept of doing ZK snark proof of solvency, right? So basically you have an exchange, you want to prove to people that you're not being like Mt. Gox and FTX and you're just actually being honest. And so what you do is you just like regularly publish proofs that prove that whatever the set of balances is that users have, you actually have the corresponding amount of money like actually in addresses that you control, right? And like to me, that also is a type of you know, L2, right? It's basically a special purpose L2 that's designed for one particular application, it definitely is a server, and it's okay with being a server, but it's like trying to make the best of being a server and actually give its users more guarantees, right? Then, you know, you have things like intmax, which definitely has to be kind of somewhat on the toward the centralization side because it's a plasma, and plasmas have to have operators, but you know, it doesn't quite go all the way. And then, of course, you know, we have Arbitrum. And I think what's interesting about Arbitrum is like the choice to have these multiple offerings, right? So, you know, you have Arbitrum 1, you have Arbitrum Nova, and, you know, potentially, I imagine this might even expand more in the future. I mean, with Arbitrum Stylus, you know, that's definitely a pretty big kind of expansion from, you know, like being EVM purist toward being on the experimental side, right? And I think like different parts of this prism are really useful for different kinds of applications, right? So, you know, there's, if you're doing things that are financial and that are high value and that like lean more toward the crypto-y side, there's a lot of value in kind of you know, definitely being more decentralized, definitely being closer to the Ethereum side of things if you can. And then if you're doing something which is like some existing big enterprise deployment and you're just trying to kind of dip your feet in, then you know, you obviously want to keep a completely different side of things. And then you know, potentially we might even see like the bottom right side of the trapezoid if like AWS makes some kind of offering where they do, you know, like some kind of zk and arc verified compute at some point. I don't know, right? But you know, you do like end up actually having all of these applications, right? And I think one of the things that's really valuable for Ethereum to do as an ecosystem is like really try to have a maximum level of interoperability between these things, right? Like what's the value of all of these things actually being layer 2s instead of just like either being separate chains or just being servers, right? One of the big ones is shared security. So you have this like common root of trust and you have this like really big thing in the middle that's really hard to 51% attack, and everyone is kind of connecting in as part of the same thing. And then another benefit is, you know, you actually can have a higher degree of interoperability, right? Because if you have one of these layer 2s, and in any one of these if you're in any one of these layer 2s and you have your state inside of any one of these layer 2s, then like you can go create a Merkle branch and then you can provide that Merkle branch to someone else. You could potentially even provide the Merkle branch to one of the other L2s. You could basically do things like cross-chain swaps. So there's like a lot of opportunities to do interop in this kind of ecosystem, right? And so basically what this ends up looking like essentially is like heterogeneous sharding the way that people were thinking about it 5 or 10 years ago, right? I think the challenge with doing heterogeneous sharding at layer 1 is basically that like there's potentially a lot of heterogeneity that you have to try to satisfy. And then there's like this very uncomfortable question of like, well, if you're giving anyone less than the maximum degree of security, then you're basically accepting that there is someone that has like some non-zero chance of something happening to them, right? And once you accept that, then like from the point of view of the L1, it's like, well, what do you do if something actually does happen, right? And so it becomes this kind of very weird thing, right? With this L2-centric approach, we're basically saying, you know, L1 makes this like very hard commitment where L1 just says L1 stands behind every single bit of every single cycle of execution that happens on the execution layer, and it stands behind every single byte that is on the data availability layer, right? In Ethereum chain, where even one byte is missing is not a valid Ethereum chain. But then if you actually want to have things that kind of scale up in a way that's more accepting of kind of more specialized trust models, and you get things like scaling benefits as a result of that, then like these are things that you can do in all kinds of ways at layer 2s, right? So you can take on the risk of data being unavailable by using some kind of alternative data availability source, and then you have Validium, or an Optimium or whatever. You could take on the risk of having a new VM or a new programming language, and then if there's some kind of bug there, then the risk is on you. But if you can do it right, then the benefit is on you as well, right? And so you basically have the ability to essentially have these kind of shards that have all kinds of different properties, where you can spin up any of them at at any time you want for any particular application, and the Ethereum ecosystem actually manages to serve all of these things, right? So basically, I think my view is I think it's good that we have different projects that are pursuing different paths, right? So Arbitrum is clearly taking on some part of the design space, like a particular region of the prism that I'm describing here, which I think is good. But at the same time, you have other projects that are exploring very different regions of the prism, right? And so I think that's good, both for kind of just the broader ecosystem being robust against all possible futures where we don't yet know, exactly what kind of things make the most sense. And it's also good because we already know that for different applications, different things make sense, right? If you're making a game, you don't need the same level of security as if you have a high-level financial application. And then even within a game, $1 million sword needs more security than every single move that every person makes every 150 milliseconds, right? Now, you probably still want some security for the 150 milliseconds, but it's definitely not the same challenge as trying to protect the $1 million sword, right? And so you have architectures like Farcaster, for example, right? That's using a CRDT for the tweets, but then it's also building on Optimism for the actual for things like usernames and accounts and other kind of uniquely high-value information, right? And I imagine, for games that are being, built on top of Arbitrum or wherever else, there's often going to be a lot of value in a similar kind of architecture, right? So I think it's good that that you're offering different form factors. I think it's good that we're pursuing different paths. I think it's also good that we're increasingly really starting to care about interoperability between these different paths, and I'm really looking forward to a lot more of each of these categories of applications getting out there. So thank you, and look forward to seeing what you guys build.